as usual. So maybe these 2 topics or 3 topics will be tested in your test 2. So sekarang I will share the screen. Are there any problems? Anything you want to share? You can interrupt me anytime during the class. Kan? Sebab I cannot see you. At least lah, if any problems, straight away you can interrupt. Screen. Start broadcast. Okay, you nampak tak saya punya, can you see my screen? Okay, thank you Siti. So okay, now we will learn apa ni, a more challenging topic. Taklah challenging sangat, not really challenging. Just you know the equations to be used. I think should be no problems. Okay, this topic will be included in your exam, final exam for sure. Okay, this is one of the topics to be covered in final exam. Okay, so transient heat conduction. I hope all of you know what is transient heat conduction. Sebab before this we learn about steady heat conduction. Okay, steady means that the temperature or any properties in apa ni within a medium will not change with time. But for transient, it is vice versa, meaning that it changes with it too, meaning that the temperature maybe changes with the time. Okay, so that we call as transient. And then can you see the term heat conduction? Guys. Ya, terputus-putus ke my line? Okay, nasib baik. So heat conduction. What can you infer from the term heat conduction?
Heat transfer.
Memanglah heat transfer, heat conduction. Tetapi inside a solid medium. Yeah? When we are talking about conduction, the medium is a solid medium. Yes. When we talk about convection, the medium is surface and the adjacent fluid. When we talk about radiation, apa dia? Surface and surroundings. Okay, itu you have to know how to identify those modes of heat transfer. Okay, bila saya kata conduction je, okay, terus okay, this is solid material. So what you need to know about solid material? Okay, I must know the K values, maybe diffusivity ke apa, everything to do with the solid medium. Yes, K apa thermal capacity, apa specific heat capacity, density,
Thermobility.
yes, that is conduction. So you see that term straight away, okay, this is solid, and then anything you can refer to a solid materials lah, bukan fluid like air, water, steam. Okay, itu maksud dia. So now as I've told you, okay, transient means apa ni? Temperature in a body at any point changes with time. That is transient. So ataupun the term variation of temperature with time as well as position in one-dimensional systems. Meaning that in our case, we just focus in one-dimensional system. Meaning that kalau X direction, only X direction. We won't consider Y or Z directions simultaneously. Okay? Itu maksudnya. we can consider y direction, but one dimension only. Ya, dia tak berlaku secara simultaneously for the 3-dimension systems. Okay, and then bukan dimension system. Yalah dimension system, betul lah. Dimensional systems. Okay, one of the method, okay, kalau last in our previous chapters, all the analyses are about what? How to determine the heat transfer rate, betul tak? How to determine the temperature, betul?
Betul.
Okay, for this case pun still the same, tetapi method to do the analysis is different. Kalau macam last time you go use Fourier's law of conduction, everything kan. So for this case, when it is about transient, there are different methods lah, ya. Because we have to consider time and also positions, meaning that the independent variables usually two types of independent lah kan, variables, temperature, time and also position. Okay, one of the method we call it as, saya bercakap tak tunjuk kan, analysis of, we call it as lumped system analysis. This is one of the methods used to do heat transfer analysis of a transient heat conduction. Yeah, so where the body, okay, transient, when we are talking about transient system analysis, nama dia lumped system analysis. This is the name of the method, yeah, lumped system analysis. If we are using this kind of method, okay, the thing that we have to apa dia panggil, berhati-hati, careful, it only, kalau you baca sini, the temperature of the body varies with time but it remains constant ataupun uniform throughout at any time. Boleh faham tak that statement? Somebody? Senang je jawab. Siti, cubalah. No, cuba. Try to. Ya, Apa dia?
No, tak faham.
Memang tak faham? Okay. If you consider lump system analysis ni, only the temperature change with time. Okay? Tetapi the temperature is not change with position. Only with time. Meaning that the temperature is the function of time only. Okay? It is not function of times and location. Understand? No location, only time. So if this is the case, we can use lumped system analysis as our method. Okay, faham tak yang tu?
Faham.
Alright, meaning that the temperature depends on the time only, not locations. Okay? So, now let us move to slide number 3 ni. Okay. The name of the method is lumped system analysis. Okay. In this slide, I show two types of medium. Because this is conduction kan. Of course lah, material that is solid. Two types of materials. The first one is copper ball and the second one is roast beef. Okay, I want to ask you, which one the size is bigger?
Roast beef.
Yes, beef kan? Sebab copper ball is very small. Okay, usually we use copper ball in a thermocouple. It's very small and we can sometimes see it. Yeah? With our eyes lah, sebab it's very small copper ball ni. Sometimes and also kalau saya selalu lupa that term, that device, yang ball banyak-banyak, ball bearing. Do you know about ball bearing? Yes, copper ball sometimes is used to is used for that device, ball bearing kan. Ball bearing is used to what? To make to facilitate it to move kan at any angles. Betul tak? Betul tak, engineer sekalian? You all tahu tak ball bearing guna kat mana? Macam-macam tempat lah. The ball bearings is dia punya applications very so many applications use that kind of concept lah, ball bearing. So copper ball is like a ball bearing, very small compared to roast beef. Okay, let's say lah copper ball very small. Let's say the diameter is 0.3 cm, 30 millimeters. And then the roast beef, I think maybe roast beef 300 millimeters. Okay, and then you expose those mediums in warmer environment. Okay, warmer environment, and then I know for sure the copper ball will reach certain temperature ataupun higher temperature kan, faster compared to the roast beef. Agree?
Agree.
And then the temperature also uniform throughout the copper ball compared to roast beef. Betul? So, lung system analysis applicable to copper ball only, not roast beef. Because roast beef dia punya density of volume is quite big in size kan, and then the heat transfer rate pun nak penetrate through the daging, the meat tu is not as easier as the copper ball. Because of that, the temperature distribution is not uniform. Senang kan? Betul tak? So because of
Saya setuju.
okay, setuju kan? Okay, because of that, roast beef, if you see this, the temperature changes with location, right? And also time. But for a copper ball, the temperature does not change with location, but only change with time. With time, it changes. So this cannot be used. Cannot be used. The lump system analysis cannot be used to solve any heat transfer analysis lah. Tetapi we can use lump ni untuk estimation, just approximate. Tak ada masalah, it's okay. But maybe it's not accurate, yeah. But it can be used for copper ball type of medium. Okay.
Doktor, kalau real world
Yeah.
condition, selain copper ball apa lagi ya? Boleh buat lump system analysis kalau real world application.
Okay. Okay, apa lagi apa? Okay, let us think together. Yeah, betul lah tu. What else? Something that's more, okay, maybe your pencil.
Pencil, okay.
Kan? Your pencil maybe because
Small enough, yeah, small enough.
yeah, small enough, meaning that the temperature is uniformly distributed. Kan?
I see. It must be really small lah. Taklah small sangat.
Not really tiny lah. Tiny lagi better lah. Tapi dia ada certain. Okay, but we can measure it whether suitable or not to use lump system analysis. Ada.
I see. I think I see.
Yeah, okay. So bagus
Thank you.
you punya soalan. Okay, the what we call the property to measure whether a material suitable ataupun lump system analysis suitable to be used for a solid medium, we call it as bio number. Saya tunjuk dulu, nanti saya akan patah balik. Bio number. This is bio number. We have to check whether your bio number is within certain range. Okay. If your bio number is less than 0.1, definitely you can use lumped system analysis. Okay, if your bio number is greater than 0.1, definitely you cannot use lump system analysis. Okay, meaning that we have a method, a mechanism to evaluate whether any medium can use lump system analysis or not. Okay? So, yeah. Yeah? Meaning that like this, you can use it. Bagi saya, because nanti ada one example, I will discuss with you, ada one example, a body, a dead body, you want to measure how long, bukan how long, we want to measure how long this guy die. Okay, by using lump system analysis. Although the body is quite big, but for approximation, dia panggil apa tu, early investigation before you do the scrutiny, before you do scrutiny, before you scrutinize your analysis using method yang canggih, bukan canggih lah kita panggil, yang soft, yang complicated, this lump system analysis can be used as macam earlier lah, sebagai ada macam estimate lah, okay, at least pukul berapa ya dia mati before you do further investigation. Nanti ada one example, maybe I will share, I will discuss later but no worry about that, Siti. As I've told you, I always tell you what I always tell you. If you want to use any type of equations ke teori ke or any, you can use it but with realistic justifications. Sebab tadi pun I discuss with my colleagues about your final exam whatsoever tu lah kan. We assumptions got marks. Yeah, although we not explicitly inquire ataupun request it, yeah, but assumptions have marks. Itu I want to tell you that, yeah. So make it as your panggil habit lah. Mesti ada assumptions, mesti ada justifications, okay. So you tak kurang lah kot sebab dah ada markah. Kalau 25, maybe 2 or 3 assumptions marks, surely lah your mark will will reduce. Kan? Logically right that kan? Dia bukan ada bonus. Bukan kalau ada assumption dapat bonus. No. Pandai. Okay. Now, in this slide, I want to share with you how the lump system analysis equations derived. Okay. Although we won't ask you to derive the equation, but it's not appropriate if I just tell you, okay, this is the equations without knowing where it comes from. Betul kan? Pandai. Siti seorang je yang pandai dalam kelas ni. Okay, tak adalah. Semua pandai, semua pandai.
Betul.
Amboi.
Betul.
Sedih
Yeah.
tak? Sedih tak? UTM PKPD.
Nah.
Sedih.
Jahatnya.
Kesian kawan-kawan.
Sedih doktor.
I can't enter the campus, you know. I can't
Me
enter the campus.
Majority staff yang bawa COVID.
Sukati je. Saya tak masuk UTM langsung sepanjang ni. Saya memang tak suka. Biasa duduk kat rumah. Better and then tak payah terkejar-kejar. Kan? Everything all fingertip at your fingertip. Selalu nak guna that term tapi lupa. So okay. Now we look at this slide. I think all of you are easy je ni. We usually base on energy balance. Okay? We always derive heat transfer equations based on the energy balance on the body. So based on this, we can see that the energy balance on this kind of body can be defined as heat transfer into the body during dt into the body equals energy increase of the body during dt. Due to the heat transfer, okay, due to the heat transferred into the body, of course lah the heat inside the body increases, kan? Okay, that's the simpler way to explain about it. So, from here, you can see heat transfer into the body. This is the formula. Heat transfer into the body. Q, ini convection, right? Because this is a phase, and then convection enter through the boundary. So this equals to the heat received by the body. Senang je. So energy increase of the body. Okay, so this, let us move to the next slide. So means that this is the heat transfer into the body, and then this is heat increase during the time dt tadi. Understand M, Cp, delta, T. Okay, this one you learn during thermodynamics subjects. Yeah? And then T is T of what? T of the surface. Yeah? And then T infinity is the surrounding temperature. Yes. Oh, kan? Now let us look at this. Okay. Faham kan? Senang je. So, let me check first. Ni dia tulisan dia macam sama ke tak? I have to check. Actually, this is not my lecture note. Itulah saya nak cakap. Sorry. Okay, tak apa. Let me check back. Ni H, I have to check now. T, okay. Now let us read this before we conclude the equation. Okay, dia kata consider a body, okay, that is initially at a uniform temperature Ti. So the temperature inside the body is Ti, initial temperature. Okay, and then at time T, T equals 0, the body is placed in a medium at temperature T surroundings ataupun liquid ataupun fluid temperature near to the body, okay, T infinity greater than Ti. Of course lah, if this happen, the heat will transfer into the body because T infinity greater than the initial temperature. Betul kan?
Betul.
Yes. Okay, then the H, okay, let's say lah the environment, we know the convective heat transfer coefficient. Okay, so the energy balance, of course, this T infinity minus T during time 0. Agree? That is Ti lah tadi. Okay, now we move to this. Okay, so noting that M is density times volume of a body. Betul kan? Now ni lah saya lukis. This is your solid material. And then the mass we know and the mass we don't know. Selalu kita tahu apa? We know the volume and the density. We know the volume and we know also the density of the medium. So very easy for us to calculate the mass, that is density times the volume. So the unit is kilogram. Then the dt here, can you see? It is the difference between the initial and the temperature, surrounding temperature. So if you rearrange, okay, replace, substitute everything, rearrange, you substitute, and you will get this form. Faham ke tak? H, A, this one, okay, let me write it back. So this one, if you rearrange, it becomes like this lah. H, A, S, the M, we bring down here, and also the Cp based on equation 4.1. And then is equal to dt over t minus delta t infinity. And then dt is this. Betul?
Betul.
Right. Now,
Apa beza atas sama bawah doktor?
apa beza atas and bawah? Nothing different. Same.
So,
This one, you mean this. But from here, this one is differential. Differential equation cannot be cancelled out.
I
You
thought
have
it
to
can be
integrate.
cancelled out, doktor.
Cannot. This is differential
Oh.
equation. Okay, differential dt, differential. So cannot be cancelled out. You have to integrate. That's why you cannot cancel out. So integrate, it becomes like this. Kan? Integrate from t0 equals 0, at which t equals ti, to t at any time lah, given. The given time. Kan? Ini mathematics So t, this one, t at any t minus t surrounding, divide this one is of course lah the initial one. Ti, t infinity, this one remain. Okay? Can you see this one dt? Comes from here, right?
Yeah, doktor.
Okay. Now with time, because we are considering watt, joule per second. So finally, you rearrange and use mathematics solution. Finally, you will get this equation. So this equation is very important in your analysis when you use lumped system analysis. Very important. Why? Based through this equation, you can determine either your T at any time, initial temperature, or surrounding temperature. And B, small b ni, dia create a property, like a constant, this B, to remove, bukan to remove lah, to hide this very orang kata banyak sangat the things to be carried out kan. So dia to represent these 4 or 5 parameters. We call it as constant B. So this is very important saya tanda, and then you pun must do something lah, jot down whatsoever. So during your exam or test, you know what equation to go straight away without nak buka selak satu persatu. Okay? So any question? Senang je. Saya dengar tadi Prof Norma told us, okay, this is like a bonus to students. Dia kat jantung tadi. This section, this chapter. Bonus tak?
I think yes.
What bonus, doktor?
Bonus tu mean easier. Dalam all the chapters, this is the easiest. So macam kita kalau give this question bonus, this is the bonus. This is soalan bonus panggil.
Doesn't include the derivation, right, doktor?
Yes, no. We won't. InsyaAllah. We won't ask student to derive.
InsyaAllah.
InsyaAllah. Rasanya ya. Betul lah, saya rasa ya. Saya tak dengar apa tadi tentang derivation.
We have a trust issue, doktor.
What is the issue? Ada?
We have
Okay, have what?
nanti during our final or test tu nanti derivation akan tanya.
Tak. Kalau ada saya akan cakap. Itu saya. Tapi saya akan bagi tahu, but I tak adalah explicitly what equation to be derived. Tapi okay, from this page to this page. Saya like that lah always. I won't lah explicitly.
Thank you, Doctor.
I will tell you if there is derivation. So okay, for now you just use this equation and you solve the problems. Any problem related to transient conduction. Okay, if you look at your lecture note for chapter 4, can you see it's very short ataupun the pages is quite macam not many. Kan? Ke you all tak tengok lagi your lecture note that I have shared just now, this morning before the class?
Yeah, 70 page.
Yang lecture this one that
17
yang
je.
17 only, right? So and then the rest I have deleted. You know why? For transient we only focus until lumped system analysis. Although there are several methods, kan? Memang that's our scope. That's our scope. If you don't believe me, try to check your course information.
We believe you, Doctor. 100%.
Okay. Okay. Thank you so much. Kan, kau tak percaya pun buat percaya pun salahnya kan. Okay.
No,
Now,
we really believe in you.
okay, good, great. That's good. So it will help you to apa kata kalau kita percayakan guru kita je mudah je ilmu tu masuk kan. Okay.
Yeah, Doctor.
So, alright. So now, this one we call it as apa dia, the B ni is actually constant lah, time constant, yeah. We call it as the time constant. Sometimes I always call it as a macam constant je lah, yeah. Time constant because the unit is 1 per second, yeah. That is why it is called time constant. Okay, now, can you see there are berapa so many, ada 3 equations of heat transfer rate. Okay, kalau you which one to use? Maybe you get confused, which one to use? There are 3 equations. But this one, the unit is watt. This one is kilojoule. And this one is also kilojoule.
I think it's depend on question.
Yeah? Yes?
It depend on the information
Yes.
in the question.
Yes, you are correct. Siapa nama dia?
Alani.
Oh, Zuki. Kenapa panggil dia Zuki?
Sebab Zuki.
Nama you apa sebenarnya? Muhammad Alani kan?
Doktor, bukan saya. Itu Marzuki.
Zuki. You all ni apa ni? Mentang-mentang lah saya tak nampak nama. Suka-suka. Oh, yang tadi tu Zuki. Alright, okay. Ini yang Marzuki Tom apa? Ada Zuki. Ada saya nampak nama macam.
That one doktor. Not Alani.
Yang bunyi, macam pelik namanya. Apa Zuki Tom? Betul tak? Zuki, what is your name? Your real name?
My name actually Tom is my father's name.
Okay.
So
your name?
My name is Marzuki. Yes,
Marzuki bin Tom.
bin Muhammad Tom.
Muhammad Tom. Oh, okay.
Yeah.
That's why I want to know where the Toms come from. Okay lah, Muhammad Tom. Okay, alright. Okay.
Tom is my father's name.
Okay, good. Okay. Tak nak cakap nanti ayah dia. No, we cannot talk about our parents. Okay, alright. Now we continue. Okay, based on the information given, and also if you see or if you can differentiate between among these 3 equations. Okay, so the first equation 4-6. Okay, equation 4-6 here. Okay, the rate of convection heat transfer between the body and its environment at that time can be determined from this. Meaning that you want to know how many heat being removed or being transferred into a system or a body during that time. The exact time. Nampak tak? At T temperature 5 seconds. What is the heat transfer rate? So this the equation to be used. Because the temperature value is the temperature at that particular time. The time that we are considering. Faham ke tak? Okay, easy. Okay, what about this? The total amount of heat transfer between the body and the surrounding medium over the time interval T equals 0 to T is equal to the change. Okay, this one, okay, is the heat transfer rate from the initial condition to the time that we are considering.
Oh, certain time lah, doktor.
Meaning that initial dia, okay, let's say the before we do the analysis, the initial temperature is 20 degrees C. And then when we transfer heat into the body, so this at certain, I don't know lah, maybe 20 seconds after that, the temperature rises to, let's say 50 degrees C. So we want to know how many heat being transferred during this process. Macam tu lah lebih kurang. Boleh senang sangat.
Boleh.
And then the final equation is the maximum heat transfer, bukan heat transfer rate, heat transfer, kilojoule, right? Meaning that the initial temperature, you have this body. Okay, the initial temperature, let's say 20 degrees C. And then the surrounding temperature, before we do anything lah to the body, is let's say 70 degrees C. So this is the maximum the heat transfer can happen, right? Between these two temperature. It won't beyond that. Betul tak? That we call as maximum. Maximum. Okay? The possibility the system receives heat from the surroundings at that particular temperature. Macam itulah, T surroundings temperature. Okay? Okay, now, so this is the criteria to, saya just give theory first. We won't discuss anything about the example yet. We will do the example discussion next week, on Monday. Now I just complete the theory part of this chapter. So criteria for lumped system analysis. So how to determine whether any body itu can be analyzed using lumped system analysis. Okay, to do that, we have to determine bio number. Yeah, we call it bio number. And then the bio number is defined as the convective heat transfer coefficient, characteristic length, we call it LC, divided by the thermal conductivity of the body. So, how to determine characteristic length? So this is the formula to determine the characteristic length. You have to calculate or determine the volume of the body and then divide by the surface area of the body. So finally you will get your bio number. So bio number has no unit. Yeah? Okay, so this is other expression of bio number. So if you creative enough, you can play around with parameters and you will get the same answer. Okay, so if your bio number after you calculating, analyzing, blah 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 blah, and you dapat T, okay, the bio number is less than 0.1, that as a macam validation lah, for you to use this method to evaluate the heat transfer analysis of a body. Okay, meaning that if your bio number is less than 0.1, or you can tell yourself, okay, the body has temperature, uniform temperature at certain time. But if time changes, the temperature will changes uniformly juga. Tapi semua sama, tapi dia sama berubah. Understand? Dah habis. Ni we will continue discussing this in the next, bukan the next chapter, next week, next meeting. So I have shared, I have prepared the Google Form attendance. Kan? So anything you want to ask before we close the session? Okay, today I have mood to take photo because I'm ready with appropriate, proper attire lah. Tak adalah appropriate sangat, sikit-sikit je lah. Tapi saya buat kat mana dalam Oh, atas. Tapi saya buat dalam
Doktor.
my... Ya.
Today
Okay.
lagi pening. Today ada my mom and my sister dekat dalam bilik, dalam office.
Oh, yeah. So, they
Yeah.
heard my lecture?
No, I'm wearing headphones. So,
Okay.
yeah. They also have.
Yeah. So,
Yeah.
your mom also study or what? Or teaching?
She's doing work, so I can't really turn on the
Oh.
camera right now.
Oh, okay. Tak, I thought your mom also
Oh.
delivering or teaching or whatsoever. No, eh?
No. Okay.
Okay.
Thank you, Doctor.
So, okay. Yes, I accept your excuse. Yelah, dia ni selalu je kan sahaja cari alasan kita jangan percaya dia ni. Kan?
Doktor,
Okay.
saya rajin juga kan reply dalam kelas.
Apa dia?
Kalau saya tak fokus, mana dapat saya reply dalam kelas kan, Doktor?
Oh, ya ke? Alright. Okay lah, alright. So, okay, yang lain-lain, I will share the Google form attendance. But before that, as usual, we take photos so that as macam like what, Siti, our kenangan apa memory, kan? Apa ni dia panggil a sweet memory to deposit in your what? Your memory lah. Something to deposit in your memory, okay? So, apa saya dah tak boleh fokus dah kan sebab kita dah jadi transfer, tiba-tiba nak bersastra. Boleh ke? Tak boleh kan? Okay. Now, nanti saya share dulu the link and then at the same time I want all of you prepare yourself because I will ask Siti to take photo. I want to know how many of you attending my class, today's class. Wait, let me find my mana saya punya attendance sheet. Betulnya ke salah Google Sheet yang saya check jap. Please someone try to check whether this is the correct link. Tiba-tiba tu pergi ke mana-mana pula.
Betul.
Betul
Betul,
okay,
Doktor.
good. Okay, thank you so much. Okay, now let us start our what we call photo shoot. Photo shoot lagi. Tapi today I'm in my room. Tak apalah, boleh lah. No, taklah bersepah sangat bilik saya ni kan. Okay, boleh. So, okay. All of you on your camera. And then Siti, prepare. Last time Siti ada share the photos kan? Okay, Abdullah, I can see you. Alright. Okay, please on your camera. Can see the photo. I have to keep the photo to save it somewhere. As my like a history. This is like a